Welcome to Teddy Talks. In this video, we are going to look at calculations that involve Newton's second law of motion. Now, I already have 3 questions in this video, so it means in this video we are going to cover these questions. So, without wasting time, let us begin with the first question. Let us begin by looking at its solution. They are saying a man of mass 100 kilograms jumps into a swimming pool from a height of 5 meters. S is 5 meters. It takes him 0.4 seconds. It takes 0.4 seconds for the water to reduce his velocity to 0. Now, what is the average force exerted on him by the water? We know that force is equal to ma. But the question is, do we know A? We do not know A, but we know that V squared is equal to U squared plus 2GS. What is U? In this case, this man was jumping, meaning his initial velocity was 0. So if his initial velocity was 0, it means that this is 0 squared equaling to 2GS. Therefore, the velocity with which he fell in the water before coming to rest is what we are getting is 2GS. Now, when we substitute in, this V is equal to the square root of 2 times 9.81 times the distance from which this man was jumping. So, we get our calculation complete. 2 times 9.81 times 5 root of the answer. We see that this man, before landing in the water, before his velocity came to 0, when he was moving or was falling at this velocity of 9.1 v. But now, what do we know about force? We know that force is equal to m into v minus u out of time. Now, what is happening in this scenario? We are saying that the initial velocity is 0 and the final velocity we have seen it to be this before he is landing in the water. So we get the acceleration here. It means that our force is going to be the mass of the man, which is 100 times 9.9 bracket. Okay, let me write it more clearly. This is 100 and do 9.9 minus 0 out of 10. Therefore, out of time, and our time was 0.4 seconds. So 9.9 divided by 100 divided 9.9 times 100, 0.99 divided by 0.4, it gives me my force as 2,475 Newton. So this is the force which the water exerted on that man. So we have answered question number 1. Question number 1 is done. This one is answered. So next is question number 2. They are saying a man pulls a box of mass 10.0 kilograms with a force of 25 newtons inclined to the horizontal. What is the magnitude of his acceleration? So here we are going to, we're answering question number 2. We are going to begin by sketching our box. If this is the horizontal ground and this box is being pulled at an angle of, a man pulls a box of this with the force of this inclined to the horizontal at 37 degrees. That one was missing. So this is 37 degrees. So our force is along there. The man is pulling this body. Now, the force is 25, and the question says, what is the magnitude of the acceleration? Now here the question is, when the force is acting at an angle, we are supposed to find the component of that force in that direction. So now, the component of force F, the component of force in the horizontal direction, is got from F cos the angle. So this means that our force here is going to be 25 cos 37 degrees. So we get this as our Fx. So this is 25 cos 37. So our force here is 19.97 meters. But in the question they wanted acceleration. And what is acceleration? We know that we can get this acceleration from the expression F is equal to ma. Therefore, our acceleration in the horizontal direction will be Fx out of m. Therefore, our acceleration, this will be 9.97 divided by the mass of the body, which was 10.4. And our acceleration is going to be 19 point, meaning ASA divided by 10.4, which gives me an acceleration of 1.92 meters per second squared. So we have also successfully answered question number 2. Question number 2 is done, and that was the answer. So having answered question number 2, let us look at question number 3. So allow me use this space for answering question 3. Question 3 says a bullet of mass 0.04 kilograms moving with a speed of 90 meters enters a heavy wooden block and it is stopped after a distance of 0.6 meters. Calculate the resistive force to the block. Now, how do we get the resistive force? The fact that we know the mass of the bullet, the resistive force is only be got if we can get the acceleration. Now, let us try to analyze, or let's try to collect data here. The mass is 0.04 kilograms. The initial velocity of the bullet is 90 meters per second, and it moves the distance s, which is equal to 0.6 meters. But we know that acceleration is force out of, we know that force is equal to ma. Now, if force is equal to ma, what does this one tell us? It means we have to get our acceleration. But we know that v squared is equal to u squared plus 2as. Now, they are saying that the velocity, the bullet, is stopped after it has moved this distance. Now, it means that the final velocity after 60 meters is 0. Therefore, 0 is equal to the initial velocity squared plus 2a times the distance, which is 0.6. So 2 times a times 0.06, we get 1. This will give me 1.2 a is equal to 90 squared. So this is 90 squared is equal to this is equal to 8010. Then this is negative. Now that value divided by 1.2, also divided by 1.2, we get our acceleration to be negative 6,750 meters per second squared. Why is it negative? Because it is a retardation. Because they said the bullet is being stopped, and we said retardation is negative acceleration. So the resistive force F is going to be the mass of the bullet times the acceleration. So our resistive force from here, this is also times 0.04, gives me 270 newtons as the resistive force. So the third question has also been answered. Thank you.